Forest Green Rovers really live up to their name. An eco-friendly English soccer club has announced plans to build the world's first all-wooden stadium. Forest Green Rovers Eco Park Stadium will be built almost entirely of fire-retardant treated wood. This type of wood chars, but does not oxidize when burned, and therefore significantly slows the spread of fire. The stadium's roof will be covered by a transparent membrane that reduces shadows on the pitch and helps the grass on the field to grow. The non-league Forest Green Rovers play in English football's 5th tier. The club has made various efforts to go green, including installing solar panels at its existing stadium, using a solar-powered lawnmower, and in 2015, they even stopped serving meat to their players. Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews. Think that's impressive? Well, stay tuned for more eco-friendly innovations. Pipe dream no more. Imagine this, a fully automated floating city, free from government meddling, with no laws, regulations, or taxes. Once just a libertarian fantasy, it's now just a few years from becoming reality. On January 13th, French Polynesia agreed to host the world's first floating city, or seastead, within its protected waters. The seastead aims to be a special economic zone that will develop innovative technologies for solar power, aquaculture, and wind energy. Design-wise, the floating city will consist of interconnected square and pentagonal platforms made from reinforced concrete. Platforms will have a variety of structures, from residential and commercial to green spaces, with pricing per square foot on par with major cities like New York or London. The project's initial islands will cost a combined total estimated at $10 million to $50 million and will house a few dozen people. With rising sea levels threatening many Pacific islands, seastead advocates believe floating cities may be a solution. The presence of floating communities could also spark recovery for the region's dying corals by slightly lowering water temperatures in their vicinity. The Seasteading Institute will have to complete environmental and economic feasibility studies, but construction on the project could start as early as next year. Google ships are here. After developing self-driving cars, Google is set to bring its innovation prowess to the seas with a novel new ship propulsion system that uses kite energy. Google first delved into marine technology in 2009, mounting computer data centers on barges and using seawater to cool them. The tech giant's most recent innovation incorporates this technology with an airborne wind turbine, or AWT, that connects to the ship via an electrically conductive tether. The windmill-like kite consists of a number of turbines, mounted on a rigid wing, and is meant to fly over water at high altitudes. The AWT has two functions. It can be powered to steer the vessel, but can also generate power by harnessing wind energy. The ship itself is also capable of producing its own fuel by drawing out carbon monoxide and hydrogen gas from seawater, refining, and then converting it to ethanol. With a sustainable fuel and electricity source, moving data centers across the seas will not only be cost-effective, but also environmentally friendly. For now, Google is remaining mum on this exciting new technology, despite successfully acquiring the patent for the AWT in September. Cameroon turns human waste into clean power. 2 towns in Cameroon are installing biogas systems to turn human waste into sustainable energy that can provide fuel and electricity for local communities. Organic material such as animal waste is placed inside an airtight tank where bacteria and archaea break down the material. This releases biogas, which is a byproduct that is a mixture of mostly methane with some carbon dioxide. The biogas can be stored and burned as a fuel for cooking and to power electricity generators, while the rest of the waste can be used as fertilizer. The biogas system installed in Cameroon connects a septic tank to biodigesters, linked to individual households. Human waste placed in the septic tank is converted into biogas by the biodigesters, and this releases energy into people's homes. More than 3,000 households and local schools in 2 towns have reportedly installed the biogas system. It is estimated that the project may reduce greenhouse gas emissions in the vicinity by up to 60%. The project was initiated by Bioenergy Cameroon, a non-governmental youth organization. The group trains local students, especially female students, on how innovative technology like solar power and biogas work. Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews. Los Angeles breaks ground on biogas-fueled power plant. A biogas-fueled cogeneration power plant will soon supply enough energy to power a Los Angeles water reclamation facility. Biogas is gas formed by bacteria and archaea that feed off carbohydrates and fats and produce methane and carbon dioxide as metabolic waste. Biogas can be stored as a source of energy, while the remaining waste can be treated and used as a fertilizer. A cogeneration power plant produces steam, heat, and electricity simultaneously. It is more efficient than other kinds of power plants and boilers. The plants can achieve up to 90% energy efficiency, whereas conventional power plants often achieve just 33%, as most of the heat energy is wasted. The 25-megawatt plant is expected to generate more than 173 million kilowatt hours of electricity a year, and up to 70,000 pounds per hour of steam. That's all the energy needed to power Los Angeles' Hyperion water reclamation plant. Using biogas as a power source is also expected to prevent the release of about 100,000 metric tons of carbon dioxide a year, equal to the emissions from around 21,000 cars. The Hyperion Water Reclamation Plant is Los Angeles' oldest and largest water treatment plant. It has been operating since 1894.